All right, everyone, welcome today to our event on microservices and scaling applications. We're super excited to have you all here today. Who here knows what microservices are? Anybody? Any guesses? Who could tell me? Yeah? What is it? What are microservices? Yeah.
So the answer to that would be earlier is the things were designed in a monolithic, and you're asking me at the difference between a monolithic and a microservices architecture. I have bifurcated my services of an application into the smaller pieces.
Okay.
And containerized it or means put down on the layer of the OS everything running on a platform.
Okay.
So earlier it was different servers, separate down the components, architecture of the server database on different layers. Now it is on one platform, takes a platform.
And then you have these different services.
Yeah. Small services to reduce the load and achieve your task.
That's a good answer. I feel like you should give the talk today instead of Shazam.
Yeah.
Anyway, thanks for coming. Okay, fair enough. All right, welcome. It's very nice to have you. So presenting today's topic is Shahzaib Arshad. He's the tech lead at Astrolabs. He's been with us almost for 2 years now. And basically at Astrolabs, we started in more of like a monolith environment, and he's been slowly moving us into microservices. So today's talk is basically going to talk about why he decided to make that choice, and also what are the benefits of doing that from a scaling point of view. And also just to have a discussion on, is that really what the best approach is? So also we would love to get your feedback as well, if you have any comments or questions, to have an open discussion about all of this. So yeah, without further ado, I'd like to pass it on to Shahzaib to start with the talk. I'll let you share. Just unmute yourself when you're ready.
Can you see the screen now? Yeah. Okay. Yep. Right. So before I jump into what microservices are, a little bit of background on different design patterns that have evolved over the years in programming. Going back to 1960s, modular programming came in. Now, what modular programming is in terms of what we do now is packages and libraries that we import into our code base, and we can easily use them. 1980s, C++ and Java introduced object-oriented programming, and 2005 was the first time that microservices, the term was used. It was used as web-based microservices. And in 2011, Netflix and Amazon started shifting their architecture into microservices. Now, if you look at what problem they are trying to solve in all of these different design patterns is to make the code scalable, and second of all, make it maintainable, because as your application grows, the code becomes complex. So starting with modularizing it in smaller chunks and moving on to object-oriented programming, where you can have a class that you can use in multiple places, microservices takes the whole concept to another level. So this is what a monolithic design looks like. And on the left side, we have an e-commerce application. You could refer to as Magento, OpenCart, all of these platforms that WordPress itself as well. If you look at the application, it comprises of catalog, module, user profile, checkout, and you might have other modules in the code base. One of the problems is that when you're working as a developer and you're making your application, it looks very neat and tidy. You have different folders, you have the source code, you can control it very nicely. But what happens when you deploy it on the server? If you have worked with Node, you might as well be aware of when you build your project, the build distribution is like a bunch of files that you can't read or interpret at all, because they're all minified versions for distribution. Now, that is a bigger problem, because if you're not able to even understand the code, it is not easily scalable in terms of new functionality. So some of the limitations that you see with monolithic models are, if you take an example of this e-commerce application, now catalog is the module that is going to get the most traffic. User profile, checkout would be the second ones, but address and billing, if you look at them, they really get any traffic. It's just on the checkout page, we enter the details and it's saved in the database. How do you scale that kind of an application? Because if your catalog gets a lot of traffic, you need to scale the servers up, but that happens for all the other applications as well. You can't individually scale that application. Talk about updates. Let's say you work in a team and you've just hired a new developer. When they start working on a monolithic model and you need to push the code to the production level, you need to do a full QA for the entire application, because any small issue can cause a lot of bugs in the entire application because it's one big application. Choice of language. Now that's a debate that developers have been having. It will continue for a very long time. The idea is which language to choose. And when you start a project in a monolithic model, you're bound by that tech stack. You cannot change or you cannot introduce another technology within your project. Version control. Let's assume that you've just made a tiny bit of a change in one of the modules within that application. When you release the code, you have a different version altogether now, even though you did not touch any of other modules. Now, microservices basically addresses all these issues. If you were to convert, on the left side, you see a monolithic model of the same application, which is an e-commerce platform. On the right, if you see, each service has a different domain name. And the reason they have a different domain name is because they are completely different applications. Now, microservice basically means a small application itself. It has everything that would have that would be in a full-scale application, but the functionality is limited to a very specific function. Generally, microservices, they don't have an interface. They usually work with REST APIs. And to communicate with them, you either have to use a client that communicates with the REST API, or you have a view that basically connects to that backend and communicates between the services. Now, these services, they also talk to each other, because the problem is that when you have a monolithic model, all these modules can talk to each other very easily because they are in the same code base. With microservices, you also need to be able to communicate between the different services. So for example, let's look at the checkout service. When you are about to check out on an e-commerce platform, the service needs to know which product are you buying. And for that, it needs to call the catalog service to get the data from there. Now, some of the things are required in any microservices platform that you are building. What is it?
It's going to explode. Maybe just raise your voice instead.
Yeah, that's fine. I mean, everyone can hear me, right? Easy.
Just raise your voice slightly.
Yeah, that's fine. So when you're building a microservice architecture, you need to do a couple of things. The first thing is, now if I go back to the presentation, you have these different services, right? And you need to pass data from one service to the other. One way of doing it is hard coding the URL within the application, which is not a good idea, because if you have different versions that you might release, or you change the URL, you will have to go and edit the service back. The other method is to use service discovery. Now, service discovery server basically contains the information about your services and their URL. So all your applications basically use the service discovery to find the service they are looking for, and in the response, they get the URL of that service. The second thing is message broker service. Now, if you've used APIs, getting the data is relatively easy. You just pass on a request, parameters, you get the data out. The problem is when you post data from one service to the other. Now, given you have a microservice architecture, I'll give you an example. What happens when you check out from an e-commerce platform? what are the changes that happen on the system level? Any guesses? What is the biggest change that should happen in an e-commerce platform when you successfully check out? Yeah, well, the payment is confirmed. Then on the platform level, what would change? The first thing would be the catalog, the inventory of the product. You need to adjust that once the order is confirmed. The second change would be in the profile of the user to display that order. So there are a couple of changes that is happening upon each transaction. There are two ways to do that. You could either build this logic in your front end that when it receives a confirmation from the checkout service, it calls the API of the catalog and updates the catalog. But there's a problem in that. And the problem is your logic is now sitting in the view, which is the front end. And if you're deploying a mobile app as well, you will have to implement that logic over there as well. The other option is that this information is relayed from the checkout service directly to your catalog service. You will be posting data to the catalog service. This has another problem. And the problem is that when you post data, it is possible that because it is happening on the back end, it is possible that the catalog server was down, or it was busy, or it timed out. How do you make sure that the catalog service receives that message and processes it accordingly? The third issue here is that you might have some data that you're sending it to 3 or 4 different microservices, depending on what they are. And you would have to write the code 3 or 4 times to repeat that call to the API, different APIs. What Message Broker does, basically, in a nutshell, it's a database that holds information. And when a consumer requests that information, it is sent to that. There are different types of it. They're also referred to as queuing system, for example, pub sub, publisher and subscriber. And what they do is basically you have the concept of publisher and subscriber. So publisher is the one who's going to send a message, and subscriber can read that message. Now, it can be read either, depending on the features of the system that you use, either it will be the responsibility of the client to read the messages, regularly check for new messages, but there are some message brokers that basically automatically post the data. So if you were to use a message broker system, what would happen on the checkout level? Once you confirm the order, you would post the entire payload to your message broker system. All the subscribers to that queue would automatically get that message. So you're making one call, and all your microservices that need that data would receive that data without even asking for it. The other function that message broker system usually have is a retry system, where if the message broker posted some piece of data to an API and it did not get the response that it was expecting, it can try again after some time. So that ensures that your messages are delivered to the service, irrespective of the state they are in. GraphQL is another interesting platform that you could use with microservices, and it allows you to basically combine multiple APIs and serve the data. So going back, so for example, if you were for a reporting purpose or whatever you might need, you want the data from catalog and account, both at the same time. What do? 2 options. First option is you take the account, get the user ID, make another call, get the products that they purchased. Or you could use GraphQL, which allows you to program and simulate the API response. So you could actually program it in a way that it makes a call and automatically makes another call to the API and sends you the data. But in that case, you would be making only one call from the client to GraphQL. The GraphQL would handle the rest of the calls and it will prepare the data for you. There are multiple ways to implement microservices. It doesn't matter, you have to follow these guidelines. But in my experience, when you have at least the message broker system, it helps a lot when you're scaling and you're making more applications, because even with service discovery, you would have to make a call. But if you use message broker system, all you have to do is make, for every single event, just publish the message to the queuing system, and it would take care of where the message needs to go. Now, advantages of microservices. Why would we prefer using microservices instead of using a monolithic model? Scalability is the biggest factor here. If you have a service, especially an e-commerce platform or any other high traffic area where you have certain components that require some traffic, some don't, in that case, you could just eventually increase one of the microservices bandwidth and you're good to go. You don't have to increase the entire server. Development and deployment is easy as well. Your teams basically can work on an individual microservice. You can have 10 versions of one release, and you could have one version for the rest of the platform. It doesn't really matter. This is interesting, the idea of using multiple languages for building your project. There is the debate that, okay, XYZ language is better for web development or application development. But in my opinion, the reality is that certain languages give you an advantage in a certain situation. And so if you're building a microservices architecture, you can basically choose any language that you want to. It doesn't really matter. Version control is easy as well. At the same time, you can have different versions and serve those versions through your service discovery, and the rest of the microservices can find them and use. You don't have to touch the entire base. Any questions? Yes, well, the idea is that each service is an application in itself. So what language do you work with usually? Python. When you have a Python application, you would have a certain thing. So you have a model and you have a controller for that, for the requests, right? So when you convert it into a microservice, the idea is to reduce the functionality that it does, but at the same time, it has the basic features, which is the database access and the controller. So it would act as any application that doesn't have an interface. The only way to access it is through an API.
So define the separate APIs. We can relate that. If we have multiple APIs that are serving a specific purpose.
Correct.
We can say that it's a microservice.
Yes, I mean, so microservice is something like you cannot define. There is no strict definition of how deep you have to go.
But it's an
correct. It's an approach. I mean, the more you break it down, the easier it gets. The bigger chunks you keep in your system, then they're somewhat monolithic. So if you, for example, if you install software on Windows, now this doesn't just apply to web services, it applies to desktop applications as well. So if you install certain desktop applications, they use certain services from the Windows OS itself, right? So those, you can define it as a microservice, right? But the package itself, it's like a monolithic model, but it's using certain services from here and there. So there's no strict definition of it. It is similar. It is not, because in service oriented architecture, you're very specific about the service that you are serving with that API. The flexibility that you get with microservices, I mean, they are interchangeable terms, but the idea is that you could go as deep as you want to. You could have an API that does 2 + 2, doesn't matter. And you can have a service that is complete calculator, and that could be also a microservice. So the idea is that they don't do anything on their own. So for example, the catalog service doesn't do anything on its own. It needs the other services to be there to do something. Correct.
Let's say checkout needs to checkout process needs to item talk to the network.
Correct.
Without that,
Exactly.
because all of them access the same.
Yeah, so some I've seen some developers who use a single database for different microservices. I mean, there's nothing that bad about it, but again, it limits it's you know, the whole purpose of having a microservice is that you distribute that service differently. So you could still build this thing with a single database, but eventually if you need to scale it up, your database is what gets affected, because you could be running these applications. If you have their own databases, you can Dockerize all these applications, or you could use some cloud app engine or something, as long as it has its own database. So ideally, it should have its own database.
I have something from a deployment perspective. So I have currently my backend is with one Docker that I push. Ideally, subdomains are basically to have different containers.
Correct.
So each microservice I'm going to push it as a different container.
Correct.
And then assign the resources.
Exactly. Yeah. So yeah, the idea of domain is just to identify it. You could have different IPs on a local subnet.
For example, in Hadoop, basically an application ID that we
Yeah.
can have a separate set of backend applications running.
Yeah.
Assign resources.
As long as you have the IP of that container, you can use it.
Maybe I can give it here to get there. So message broker concept is also separate application.
So message broker system is usually available. It's a server. You can call it as a server. It's an application. They're available in different designs. You could have RabbitMQ as an open source platform, and you just register your subscriber and publisher. And as long as you keep sending messages, it will keep reading the messages. And depending on which platform you use, Google has PubSub. And the good part about that is that when you publish a message, the client does not have to go and read it. It automatically posts that data to a specific endpoint that you have. So that takes care of a lot of things that you would have to implement in the code.
So I'm breaking my existing monolithic design. Then basically I have to have it's about just cutting down the full configuration.
Correct, exactly, yeah.
With the message broker.
Yeah. Message broker, again, it can work without message broker, but it is just to make sure that the message was delivered. It only works when you have post messages. For get message, you can just directly call the API and get the data, no problem. Anyone else? It depends on the design that you're using and resources. So for example, if you're a startup and you have a WordPress website, I wouldn't recommend breaking it down. It depends on what you are trying to build and would it help? Well, anything that is going to scale, right? So if you build a new platform, it depends on the traffic as well. We started doing it for our website, which is astrolabs.com. We started doing it for that. And the reason we did it, so there are certain advantages that you get over monolithic model and over microservices. When you're using microservices, you readily have API available for everything. And you could then integrate it with something that is like a message broker. So in our use case, even though we did not get a lot of traffic, but we were scaling the functionality of the site. So if you're scaling the functionality constantly, you're adding new features, it's good to start with microservices because it then becomes easier to add new functionality instead of touching the entire code base. But if you have a project that does not get a lot of hits, it's a standard website, there's no need to go for that path because it will cost you more money to build it.
Is there any limitation for a microservice?
Not that I think of.
Things which are going on.
Ideally, so one thing I forgot to mention, ideally with microservices, you're supposed to use, it's recommended that you use NoSQL based databases. Because when you have a relational database, sometimes you might get stuck, or you have to package more features in one application. So it's easier to use NoSQL based databases. Otherwise, I don't think there is a limitation as to what you can achieve with microservices. Correct. I think it will survive. See, you have to see a lot more things to it. So for example, if you have two microservices and they don't sit in the same subnet, because usually they communicate with the REST API, right? So for the REST API to work, you need to have some sort of server that serves the data. If you don't have them in the same subnet or the same machine, for example, that could cause latency issues. Because if you have a monolithic model, suppose you want to get data from catalog and accounts. How do you do it? You write one query to get the data. But with microservices, you are making two API calls. It's not one. And if they communicate with each other, then there's another problem, because if they sit far away from each other, the latency between the networks is high, and you would end up with data that is late. It's not going to be quick. So when you're building it up, you have to consider all these factors. Well, again, it would highly depend on the functionality that you are trying to build. Because if you talk about big data and all these platforms that you have on cloud, they already work with APIs. So I don't see a problem in doing that. But it would boil down to the limitations that you might get. If it's a relational database, it will be a pain. If it is not a relational database, then it might not be a big issue, but combining the data then becomes harder as well. So if you have a document that needs to go as a document, there's nothing you can do about it. Anything else? Ahmed, do we have anyone else speaking? Because I'm done with my presentation.
Okay. Any questions anyone wants to talk about? I guess what are some of the negative things about microservices?
Time. You need good developer resources. Operational cost is high. You would need at least good DevOps team who knows how to deal with the broker system and all that, queuing systems. Monolithic model is just one developer building it, deploying it on a shared server that works well. For microservices, you need a cloud environment. You can't share it on a shared hosting. So that's cost only. That would be a problem.
Is there any cloud environment which actually is friendly to microservices?
Microsoft Azure does that. I find it easier than Google Cloud and Amazon. All of them, they have the functionality.
Easier.
Azure was easier because I mean, when you're using cloud, in my opinion, the biggest problem that I see with Amazon is the interface and the way they segregate the services. With Azure, it's much more easier to look at. And the same problem happens with Google Cloud as well, the naming convention as well. So Azure would be, I think, the easiest if you're starting with cloud. If you have experience, then you can experiment with other platforms. But if you're starting it for the first time, then Azure would do the job. Thank you.
All right, thank you, Shazir.
You're welcome. You want me to?
All right, if you could just stay there for a sec. We have one more speaker coming in as well. I'll let Hussam introduce him.
Well, thank you everyone for coming in here. As you know, today's session is part of a series that we're doing every month. We're 4 different entities. Myself, Hussam Mohsine, I lead the Microsoft Reactor for Middle East and Africa. where we are a developers and startups hub, where they come and all the members come to meet, learn, connect, and to local peers and learn from industry experts all about what's happening in technology and the open source space as well, from Microsoft team, cloud advocates, MVPs, RDs, and I'm gonna get into that. And we're lucky today to have one of our RDs for many years and who recently also joined Microsoft media team, joining us today to also add to the topic. We have been doing, again, the series together. Once a month, we gather at Astro Labs to talk about technology, a topic that one of these different 4 entities, so we got Astro Labs, the Microsoft Reactor, IBM, and AWS. We alternate on different topics. Each one will discuss a topic, and this is a good opportunity for all of us to gather and share these thoughts about these topics. We also have been doing some hybrid events as well as part of Cloud Advocates visits, and also as part of expert speakers visiting us in the UAE, like Darwin. And I would like to invite Darwin today to the stage to also give his thoughts about the topic, and also he's a great international speaker. As I said, he's been an RD for over 17 or 15 years. I would need to look into. Yeah, we stopped counting. We are lucky that you also have been visiting us here. Yesterday we did a great session in the Middlesex University, and today we would love to hear your comments on the topic and what you can share with the community here. And we have this also online, so it's a mix of both audiences.
That is me. Hello. Hey everyone. Okay, do I need to stay here?
Yeah,
it feels very limiting for someone like me, because I like to move. Okay, so I don't have any prep, to be honest, but I have some notes, thankfully, while listening to our previous speaker. Is he here? Okay, before he comes back.
Do you disagree with what he said? It's like, forget everything he said.
No, here's what I'm gonna do. I'm gonna play the devil a little bit, right? Because, I mean, whatever, Netflix is using microservices, people are, going crazy about microservices. And there is no, there's no magic solution that's going to fix all of your problems. And I felt like some of your questions kind of tried to dig into that part of the story. Like, is that we need the location still after the event, right? So, okay. So you were kind of trying to dig in and try to understand, this shouldn't, is this like there's no problems about it? It's just this, blue skies and everything is beautiful. Is that it? It's not, obviously. So you have heard a lot about the things that you have to do to get a proper microservices implementation, right? So you have things like, okay, let me go with the notes here. I mean, long story short, you get service discoverability, one of the problems, right? I'm gonna define it as a problem, because if you build a monolith, you have no such thing. You don't have to worry about discovering services and scaling them separately, right? You don't have to worry about any of those, because scaling services separately and discovering services across a cluster means you're going to need to monitor all of these things, their health, and make sure they're healthy, right? So one of the jokes that I usually do about microservices, and pretty much this goes into anything that involves micro things, which is, when you have a single app, you have a single concern. When you separate your concerns, then you have multiple concerns. So do you really want to have that? So what is the benefit of having microservices? And there was a couple of notes from the slides, like, scalability, scaling individual services, not the entire machine. Wait a second. Not the entire machine, but services. So does a single server not live on a machine? So because when you say machine, it's the infrastructure, than when you say the service. So how do you separate the scale unit then? Is every service a single machine? I mean, the confusion in that sentence is because usually there are some assumptions when you talk about microservices. One of the assumptions is that one microservices is usually a container. How do you deploy a microservice? What is the scaling unit, right? From a logical perspective, if we are not scaling virtual machines or machines in this case, not entire machines, what am I scaling and where am I scaling it? Let's go with microservices and the container plus Kubernetes example, which is kind of the default one in the industry, right? When we go with that, you got I'm going to talk about this, let's assume that every microservice is a container, and then I'm scaling containers on a what cluster of VMs? On a Kubernetes cluster that lives on a particular node pool. The node pool has a set of VMs. So I'm scaling my containers. I'm saying, hey, I'm going to have one instance of this container on this VM, another instance of this container on another VM. Let's say that's what we are doing, right? Across the node pool. And then I have to monitor the health of the VMs plus the health of the containers as well, because if a container crashes, I have to recycle that. So am I scaling? I mean, if you are using a managed service that allows you to simply give your container and host it, for example, Azure container instances, right? You give your container, and there are multiple examples as well. You just give a container and you scale it. So now my question is, look up for these services and look at the pricing of these services. What you're going to see is that when you want to host a container, they're going to ask you how many processors you want, unless you are going with serverless, which kind of, if you start talking about serverless, this whole session will be another 1 hour, right? We're not going to go into there. But so it is confusing. I mean, microservices has to be, ideally, these things are supposed to be deployable separately, right? That's one of the big benefits that we mentioned. And that's really one of the big benefits. That's the major benefit, independently deployable services. So let's step back. Why would I need independently deployable services? I mean, imagine I change a code. One of the arguments that came in was that, hey, we don't have to do QA everywhere in the app. But then if you go into a microservices world and you change one microservice, the argument says that, if you change one microservice, you don't have to QA the rest of the thing. Then my question is, what about integration testing? What do we do? We don't do that because these services are talking to each other. And some of my operations that one question that was really nice is, what is the difference between service-oriented architecture and microservice architecture? The difference is that microservice architecture it's okay to copy code, and we do that. Every microservice will be totally independent, and it will have the same code in it. It's okay. The goal of service-oriented architecture is to make sure there is no code reuse. At least that's the goal, right? We try to create those services in a way there is no reuse in terms of code plus data. But if you go into a microservices concept, it's more of a usually domain-driven design where you don't really care about the duplication of the data or the duplication of code. You care more about what these services do. Because ideally, those services are being developed by different teams. That's kind of where the requirement comes in, right? Separately deployable. Why would I deploy things separately? Because I have multiple teams. They are going to need to work separately. Why would I pick different stacks in terms of, I'm building a single app. Why would I use Java and C# and Python together? There is a valid argument that some of the languages are better in some of the jobs. That's cool. But again, the whole stack, and for every microservice, I see organizations that went crazy with this, and they have a single solution with 8 different stacks. Every microservice, a team is starting with a new microservice, and they're kind of picking a random, whatever they want. And then you're having a huge human resources problem within the organization because you got to maintain these things. So you got to be very careful on that flexibility as well, not go crazy. What I would say is, the primary goal is to have independently deployable pieces. But again, it doesn't come for free, right? I mean, think about it. Let's say you got 15 people in an organization. We separated them into five people each, 3 teams. And they will be building a single cohesive solution. And every team has just one microservice. How are they going to make sure that these microservices can, talk together and accomplish a single goal? One argument might be, hey, they should never accomplish a single goal, but they will talk to each other. You're going to have an authentication service. You're going to have a product service or something. And that's where, if you go into DDD, actually you see that microservices themselves are not the deployment unit. The domain object themselves are the deployment unit. And then you're going to see multiple microservices developed as part of a single container, because container ends up being just a packaging method and the scalability infrastructure unit. That's what container is. So you have one container with a couple of microservices in it, right? Or, we can even call them APIs, to be honest, at this point. But the container itself is kind of the microservice, with having multiple REST APIs to expose multiple operations around, let's say, product catalog or something like that, right? And then that container can have a separate stack, obviously, and should have its own separate database as well. Because if you have 10 microservices or 10 containers or whatever, right? If you have 10 of those and they're all using the same database, can you still deploy them independently? I mean, it's tough. I mean, if you are able to isolate them based on tables or schemas or whatever, maybe you can, but it will still be a mess in terms of, DevOps for SQL, which pretty much no one does. But, it doesn't work. In that case, it's just a scalability unit. Then it's not the microservice, it's the container that is my deployment unit. It's not the microservice itself. So do you see the full confusion? At the end of my talk, you will be just confused, because I'm not going to give you any answers. I will just create more questions, because again, there's no ideal in terms of microservices for every organization. I would say the best thing that I have heard so far in terms of this architectural mass between microservices and monolith is strategic monoliths. And there is actually a book about this. I strongly suggest, I have no affiliation with them, go and buy the book and read it. But I would say be very careful, because you are going to have multiple concerns when you separate those concerns on all of that. Do I have to touch into anything else? Let me see my notes in here. I guess that was kind of the things that I had in mind. Most of the time, but what I do at Microsoft, by the way, let me tell you what I do. I joined at Microsoft, it's been 8 months. And my job is to help companies modernize their application or, innovate with new workflows. What does that mean? So we simply either, get an application that is, on premises or something, and it has to move to the cloud, or an application that has to born in the cloud, like build in the cloud, and we ensure that they get the best out of Azure in this case, because that's the organization I work. And me, myself, I'm coming from a background where I built, 2 SaaS startups from scratch during the span of 4 + 8 years, 2 different products. And those were all, purely on Azure platform as a service. So that's where I'm coming from. And when we talk to customers, my suggestion is always this: if the customer doesn't mention microservices, if there is no specific reason to mention microservices, do not mention microservices, because it might be more complicated than an organization wants. So again, you need to have a specific reason, or if the customer already mentions, let's sit down and discuss. Otherwise, it's gonna be confusing for everyone. Either they're gonna do halfway through. For example, again, I see a lot. They think they do microservices, but if you originally look at, there isn't an official description of it. But if you look at the consensus, again, it comes from the fact that these things should be separately deployable. every microservice should have, there should be a horizontal separation on all layers. I mean, if you have database, it should be separate. If you have caching, it should be separate. Whatever freaking hell you have, it should be separate. And especially if you are doing infrastructure as a code, this goes into a crazy other mess. So you need to be very careful. And you might see when you go out and do some research, you're going to see things like, a team should not have more than 5 microservices. I mean, obviously, this is generalization at its best, but this kind of tries to point out the problem of if you have a team of 10 and then 200 microservices, you are not in a good place. You're going to suffer because it's going to be a mess. So instead, and then you see people, consolidating microservices back into small little monoliths. One of the things that I love is the description that every microservice is an application. So maybe that's a much better definition of what they are, considering how we use them or how we can use them at best. So that's kind of my 2 cents. Any questions for me? I love it because either I have confused you so much that there are no questions, or I did a beautiful job. Oh, there's one. Right, go ahead.
When you talk about nowadays career opportunities and people saying that after a few years you will be out of market, it's still staying on the with your statement and your way of explaining that is a contradictory statement. Do you agree or disagree?
Okay, let me repeat the question. If you stay with monoliths and you have no microservices experience, at some point you're not going to be able to find a job in the market. So this is going to be funny, but what I would say is, if you don't talk about microservices in your interview, you might not get the job. It doesn't necessarily mean, because I'm going to be totally, okay. So a lot of the companies that actually position themselves as microservices implementing shops, based on my experience, 80%, this is just a number out of my whatever, right? 80% of them are not doing it right. They just pretend. They actually don't know sometimes how it should properly be done. Some of them, and some other, they just pretend because it's sexy, because it's easier to excite developers to join that company. It's like this interesting chicken and egg. I mean, you think that you should know microservices to be able to find a job, and the company thinks that they should be doing microservices to be able to find people to join the company because that's the latest and greatest. So that's kind of funny. I would definitely say do research and learn. This is definitely a trend, and this is definitely something useful when we use it in the right place. I'm not saying that I'm kind of playing the devil here. I can definitely do another 20 minutes and talk about the benefits of microservices. Definitely learn it. But I would say, should you go, I'm not arguing that a full-blown huge monolith that you have been developing for the last 10 years is the way to go. I mean, to be honest, I always look at these things, everything pretty much, architectural decisions from, the organization's bottom line perspective. What is the value that it brings to my organization, right? So if it doesn't bring any value, I'm not just gonna do it because Netflix does it. I don't care, right? That's not the perspective. So that's why a lot of organizations are going with a mix, right? Because that's as much as they can do. So yeah, it's kind of weird. I guess that's why the strategic monolith thing is the way to go. Yeah. You're welcome. Anything else?
Yeah, just one doubt regarding domain deployment. Usually you just mentioned that it's just one container that gets pushed and then everything is domain is actually deployment.
So it might be a 10 or 20 minutes discussion. So I'm not going to go into it, but the answer you are looking for is DDD, domain-driven design. Do some research on it. There are some pretty good books as well. And interestingly, the author of the book Strategic Monoliths is the author of the best DDD book as well. and I don't remember his name, which which is unfortunate. Anyway, so you're gonna find it. It's from Edison Wisely. That's the publisher, I guess. If you don't find it, just send me a DM on Twitter, and I will help you figure that out. Yeah. Sorry. One. Oh yes, exactly. Strategic Monolith and Microservices is the name of the book, correct? Yes. Yeah. Again, when I go into a discussion with a company, the first question that I ask is how large is your engineering team? Because that tells me so much about the organization. Like, what are their problems? What are their needs? Again, if you're just 8 people, most probably you're good with separating into 2 or 3 max. I can't imagine it's going to be a single team. And scaling is interesting. When you come to scaling, you need to really think in terms of the infrastructure provider, because the scaling in it is not always the service is not always about the architecture. So that's why I didn't want to go into serverless, but some argue that serverless is not an architecture model; it's just a billing model, which I kind of agree. But long story short, think about microservices versus monolith discussion. It depends if it's going to help you in terms of scaling things separately.
When you talk about building serverless, you mentioned that there might be scenarios that you have.
Give me a second. I need to come there.
I was present yesterday in the talk about serverless. I just want to be was trying to make sense of how do we create serverless microservices. So in terms that there might be scenarios where we are doing microservices and packets we are. So in terms of processing, obviously we increase the footprint and we have to definitely be getting this it's not necessary or
it might. Because again, imagine, if you are a small team, there are 2 people building 5 microservices, then most probably you have very few of them, because you will be totally in sync between the team in terms of what you do. But think about, a 100-people organization, and they're building 50 microservices. To those people, there is no way they're going to be in sync, because all these microservices will be different repos, will be, that's going to be a really they will only talk on the contracts between microservices, and they will have versioning for their APIs, so they will upgrade each other. That's what the communication we will have between the teams, not necessarily, hey, you wrote this beautiful piece in our codes, you better don't write and use it or whatever. If you start doing like, hey, you build this functionality, use it from us, then you are increasing the amount of dependency between your microservices, which is not something we want for useless purposes. Which what means useless? A microservice is a goal, right? If the functionality that you build that serves you is not your goal to expose to the outside world, then you shouldn't. Because if you do, and if everyone starts doing that, you increase the communication between services, which is an overhead. You don't want that. So you, as a microservice, you have a single goal, you accomplish that. And in order to do that, you don't want to go into, in order to decrease code reuse, if you start spinning up new microservices, then you go into a huge mess of having millions of microservices. It's not that. It's service-oriented architecture. It's not microservice. I was showing you. Oh, you are for me the service-oriented guy. You were the one who asked that question. I asked the question. All right. I'm just joking. And serverless, serverless can be an enabler for microservices development, but it's not enough. You can add a big monolithic server, and you can still benefit from the cost efficiency of serverless, depending on what programming language you use. You see the complexity. Maybe if you're going with Node, you might benefit more. If you're going with Java, you might benefit less, because the footprint of Java, considering the pieces of the code that you right? You are hosting it as service, you're duplicating it as separate pieces. You know, even if you don't, the pieces of the code are not being used, when they're warm in the memory, they might take more space than having a node application. So you might be losing a little bit of resources on that side, and then a lot of applications are using serverless. So it depends to all these variables. Okay. Cool.
Other questions? I guess if you could maybe talk a little bit about your experience at Microsoft. I mean, what have you seen in the market in terms of the kinds of applications people are building?
I am working with so many industries. It's a very large question. But
did you notice any commonality or like high-level trends?
so obviously, one of the trends is to move to cloud legacy applications, and that's a very hard place to be. And one of the things that we are trying to do, and I sincerely believe in this, is the fact that when you move to the cloud, you shouldn't simply move into VMs in the cloud, because it's not going to get you the benefits, the real benefits of cloud, right? The reason this whole cloud thing came up, I believe, right, was to be able to enjoy the scale, okay, the elasticity of the scale, plus only pay for the resources I use. And I mean, you might argue that this happens today, but not the way we wanted it to be. Here's an example. If I have an app and I want to host it, if as a service provider, you're asking me how many cores I need, you are not very different than the OEM provider that is asking me how many servers I want to procure. The only difference is when I order a Dell server, it comes in a month. When I want a VM from you with one core, it comes in 2 minutes. And that's a huge difference. That's nice to have. But I don't want to, you were supposed to be allowed, you have this elasticity, and now you're asking me some kind of a provision, some kind of an assumption, even if that assumption is supposed to live for a minute or two, and then I can come up with another assumption. I don't want that. So today, actually, serverless exists because we failed with platform as a service. We failed at that. When you go and look at the platform as a service offerings, or pretty much any cloud provider, you are going to see that it still talks about how many cores, how much memory. These were things that were supposed to be encapsulated away, and I was supposed to come into this beautiful environment where my application would scale transparently, and again, I would only pay for what I use. So right now, if you're asking me how many cores you need, if I'm not using 100% of these cores, that means I'm not only paying for what I use, I'm actually paying for what I block, what I provision, with the fear that I might use more. So we didn't get that. That didn't happen. So that's why we're trying again with serverless, and this time we're saying, okay, the scaling decision will be made on events. So it's going to be an event-driven scaling, okay? And then, for example, I'm going to mention Azure Functions in this case, the serverless platform in Azure. The billing has a unit called gigabyte second, which means you will only pay for the milliseconds of processor time you use and the amount of memory you use during that time, and that's it. So one question I had yesterday was a little bit funny. Someone asked, "Hey, what if I still, block the CPU? Will I be paying for it?" Oh yes, you will of course be paying for it. I mean, if you create a thread and sleep it or whatever, no one is necessarily looking, "Hey, what are you running on those clock cycles?" No, as long as your code is running, then you will pay for it. But that's the point. You're going to bring me the code, and when an event comes, it's going to run, and that's where you're going to start paying. If no event comes in, your application is not running. It might be in memory, by the way. For example, in terms of .NET, it's going to still stay in memory, but you're not going to pay for it. That's the interesting part. You will only pay if your code runs, and you will only pay for the memory used during that execution time. And that is beautiful. For example, in the case of, let's talk about the databases, right? Databases are a little bit more troubling. In Azure, I suppose, I actually have it for SQL Server as well. It's relatively new. So on SQL Server, we got a serverless pricing tier. Again, see pricing tier. You can scale down to 0, which is what it was supposed to be, right? I mean, if I am paying for what I use, if I don't use, I should pay nothing, right? Scaling down to 0 should really mean 0 bill at the end of the month. And you can do that with SQL Server today. You can do that with Cosmos DB, which is a NoSQL service. And I really love that because it's actually complex, but it's beautiful. So imagine you can send a query to a database engine, and as the result of the query, you not only get the data, but your bill as the result of every query. And that bill includes changes based on the complexity of your query, because it generates a level of I/O, this I/O. It uses a level of compute. It uses a level of memory, right? And all of these things are calculated together. And for every query, you get your bill for the amount of complexity you had in your query and for the amount of data read and write and the bandwidth. So you can see there's huge complexity, but this means on every layer, I'm only paying for what I use. If I change a single select statement, instead of doing, I don't know, select star, if I select a single column, my end of month bill has changed. And that's beautiful. At least I think that's beautiful. Okay? And when we go there, you really see the engineering investments return pretty nicely on your end of month. So it's really, you can show the effect of engineering investment on the bottom line. I'm going to stop unless you ask another question.
Any other questions, anyone?
You were the one who asked the last question.
Yeah.
Okay. What was it?
It's about
General patterns?
yeah, if you notice any trends in the industry. I mean, what about, did you notice like the size of the company affects what they choose, or are there any factors that determine if someone will use microservices or not? Or it's mainly on like the team itself? Who do they have as part of their team?
In my view, the size of the team is one of the very big decision points. In the view of the customer, it's an interesting question. Why do customers, unless they really know what they want, why do they want microservices? Sometimes they don't really understand what it is, or sometimes it loops back into the trend. So they heard that, because usually what the organizations do is they look for best practices, right? And that's kind of tough because as a best practice, then you look for, okay, microservices, Kubernetes, it worked great for Netflix, we should use that. I mean, Ferrari is great in Italy, but I don't think it's great in I don't know, in Turkey, for example, which is where I'm from. So I don't think it makes sense because roads are not so nice. So I wouldn't get one. So you need to select the tool for the right purposes and for the right environment, right? And that's what we are trying to help. And you need to accept the fact that the right tool for the project and the organization will change. So there is no silver bullet that's going to save you the next 10 months, 10 years or 5 years. You need to sometimes implement something for the next 2 years and then revamp or migrate to something else. Because otherwise you are paying the cost of something that you hope is going to happen, but it might not. So the long-term thinking is sometimes nice, but on the other hand, we always talk about being agile, which means do not really plan big, right? Plan small and deliver results, as fast as possible. Don't save the, 5 years ahead. Don't try to save the 5 years ahead, because as far as you go from right now in the timeline, the level of, the unknown is increasing. I guess that's pretty much it, to be honest. And we don't, to be blunt, we don't have a lot of customers. I don't get to a lot of customers who recently, I feel like this idea that both Kubernetes and microservices are costly is getting traction, because people are suffering and organizations are suffering. They're getting into Kubernetes and then they're feeling like, they're having a hard time to find people who really knows Kubernetes. And once they get into it, while they get into it, again, this is the thing, while you get into Kubernetes, you really, as an organization, you really want it, right? Microsoft will help you. I mean, IBM will help you, whatever, AWS will help you, but they all will help you because you are getting into, most probably you are moving from on-prem to somewhere, to cloud. So they're going to get money, right? They will make money. So they will help you move there, okay? Because you really want it. Maybe they're going to warn you or not. I don't know. It depends. And then you will move it. But once you move it, that you got that in your hands. You're left alone. You need to find support. You need to make sure that it's sustainable in your organization, right? And that's where they get into trouble. And this idea is spreading, I guess. The failure that they get into is spreading, and people are being a little bit more cautious in terms of getting into Kubernetes and microservices. And I see, I'm not sure about GCP or AWS, to be honest. I didn't look into those for a while. But for example, in Azure, there is a new service that's it's right now in preview. It's called Container Apps. So it's not, it's Kubernetes. So think about it. You got Kubernetes, okay? In Kubernetes, you got node pools and the master nodes. Those master nodes are the core of Kubernetes, okay? So if you go into Azure Kubernetes service, the difference from regular Kubernetes is the fact that those master nodes are managed by Microsoft, and you don't pay for them, right? The compute for the master node, you don't pay for it. So, and those master nodes are the nodes that you usually have to maintain because Kubernetes is a new version and so on and so forth. So that complexity is taken away from you, but you still have the node pools and your containers and cross-container, inter-container communication, right? And all that stuff. You still have to manage all that, right? The distribution of the images and all that. So, and that's a lot of complexity. So what if we can have some level of isolation, but we could make it easy in terms of inter-container communication? What if we could make service discovery more transparent to the application? What if we raised the layer a little bit up in terms of let's handle more complexity as a service provider ourselves, but let's not go as far as just making this a simple hosting app. still have some separation between containers so that people can have applications that are, either microservices or as simple as web and worker roles, right? Sometimes that's all they need. They need a background processing node pool because they are processing whatever images and stuff. And then they have a website, and that's it, right? They don't want to separate everything from each other. So we need to have something that can understand that these moving pieces work together and they're a single solution, but still hide away most of that complexity. So a middle ground, pretty much, right? And that's what this new service is. So I'm really happy because that shows that the need that we feel in the industry, here at least in Middle East, apparently that's a need that they saw in the US as well, because probably they're not simply building the product for Middle East. So that's a need everywhere, and it's a need as pretty large so that there is a new product coming on. And I feel like it's going to catch up, at least in Azure customers. It's going to catch up like crazy. Everyone is afraid of Kubernetes, so they don't want to go there. And they don't want to go into the app services because, and the problem with app services, and by the way, app services is the thing that hosts an app. Okay, it's hosting essentially. The problem with that is if you have a solution where you want to have 4 different deployable pieces, right? You don't want to go crazy with microservices, but let's say you are going with this approach where you have a set of microservices grouped together, right? But you still want to have that separately deployable because it's a separate team group developing, right? So when you have 4 or 5 of those, if you think from a simple web hosting layer, then you end up having 4 different apps hosted in 4 different locations, and you have to manage them as separate websites. And you have to make sure those websites are deployed in the same, data center, and the data center is not enough. You have to make sure they are in the data center in the same rack in some cases. And some of these platforms do not even give you that capability. You cannot decide where it's going to be deployed in the data center, right? So it's tough if you really want to have a solution with moving pieces, but you don't want to go crazy and still be able to scale separately and that.
So how this would affect the Azure functions customers? Because Azure functions are similar to this one. So how
To container apps?
yeah. Because I believe so you're running the calls and the same, so you don't need to worry about it. So everything is matched by Azure itself. So it looks like this, right?
So it is similar. I mean, functions is here, functions is serverless, right? Serverless is here, app service is here, container apps is here, AKS is here, learning service is here. So it is similar, but if I'm not mistaken, if they didn't change anything, so container apps, you still have an assigned core to a single container. Okay. So you are not paying for the milliseconds. I guess the billing will be seconds. I'm thinking loud, by the way. If the billing is seconds, you get so close that the billing is a huge decision point, by the way. That's one of the reasons you go. I mean, obviously there are.
Container itself.
It is, it's new, it is. So you can do that. You can host a container, it happens because of anything. The backup is
Yeah,
and that is always and I don't like that statements. What would be the benefit of functions over container apps? I mean, there are many that do not necessarily relate to the most functions because Azure functions has, triggers, binaries, and all that. So those are, I understand that it's